Okay, so picture this. You're at a cocktail party, right?
Uh-huh.
Someone asks, what's your favorite mineral?
Hmm.
You could say diamond and call it a day.
Sure.
But
Yeah.
wouldn't it be cooler to drop some serious science knowledge?
I think so. Yeah.
Like stuff that would make everyone at the party go, whoa, tell me more.
Absolutely.
And that's exactly what we're doing today.
Okay.
We're diving deep into volcanic chemistry
Ooh.
to uncover the secrets of how volcanoes create some of the most unique and fascinating minerals on Earth.
Volcanoes are like Earth's crucibles.
Crucibles.
Yeah, they forge these incredible minerals under conditions that we can barely replicate, even in a lab.
So we're talking extreme heat,
Yes,
intense pressure,
absolute.
and then this rapid cooling when lava hits the air or water.
Right.
It's no wonder that volcanoes produce such unique stuff.
Exactly. And sometimes that cooling happens so fast that the atoms don't have time to arrange themselves into a nice, orderly crystal structure.
Hmm.
They basically get frozen mid-chaos.
So instead of a crystal, you get
Glass.
glass,
Really?
a volcanic glass, also known as obsidian.
Obsidian, okay.
Yeah, it's been used for tools and weapons for centuries.
Wow.
In fact, obsidian blades can be sharper than surgical steel.
So our ancestors were rocking some pretty high-tech tools, thanks to volcanoes.
Exactly. They were way ahead of their time.
But I'm guessing not all volcanic minerals are glassy, right?
Right.
What about the ones that do form crystals?
Well, those crystals that form in these volcanic environments are often quite different from what you'd find just lying around on the Earth's surface.
How so?
Think about it. Deep underground, you've got this incredible pressure and temperatures, forcing adders to bond in ways they normally wouldn't.
So it's like volcanoes are bringing up these little time capsules from the depths of the Earth.
Yeah, that's a great way to put it.
Each crystal holding clues about the extreme forces at play down there. Exactly. And these crystals aren't just scientifically fascinating. They've actually inspired some pretty incredible innovations.
Okay, I'm all ears. Give me an example.
Sure.
How are volcanic minerals inspiring modern technology?
Take ceramics and glass, for instance. We've been using those for centuries, right?
Right.
But scientists are now studying volcanic processes, especially how those crystals form under pressure,
Mm-hmm.
to develop new, super strong materials.
So like super durable phone screens that won't shatter when you drop them,
Exactly.
or heat-resistant tiles for spacecraft.
Yeah, the possibilities are pretty exciting.
That is exciting.
By understanding how nature creates these robust materials in volcanoes, we can start to mimic those processes and engineer even more advanced materials.
So it's like having a blueprint from Earth itself.
Yeah, exactly.
This is where I start to feel like a kid again, just blown away by how cool science is. But it's not just about cool gadgets, right?
Hey.
Studying volcanic minerals also tells us something about the inner workings of our planet.
You're absolutely right. It's like having a window into the Earth's interior.
Wow.
By analyzing the composition of these minerals, we can learn about the temperature, the pressure, and even the chemical makeup of the mantle, the layer beneath the Earth's crust.
Ah, okay. It's amazing to think that something as seemingly destructive as a volcano can actually give us these incredible insights into how our planet works.
It is, and it's not just about understanding the present, it's about piecing together the Earth's history as well. Some of these minerals are incredibly old,
How old?
billions of years old in some cases.
So they're like time capsules, but on a planetary scale.
Exactly.
What kind of stories can these minerals tell us about Earth's past?
Well, for one, they can help us understand how the continents have moved and shifted over millions of years. They can also give us clues about past volcanic activity,
Oh, wow.
helping us predict potential hazards in the future.
I see. So it's not just about satisfying our scientific curiosity. It's also about practical applications, like predicting volcanic eruptions and keeping people safe.
Exactly. And as we continue to study volcanic minerals and the processes that create them, we're likely to uncover even more secrets about our planet's past, present, and future. It's a field that's constantly evolving, with new discoveries being made all the time.
It sounds like we've only just begun to scratch the surface of what volcanic chemistry can teach us.
Absolutely. We've just dipped our toes into the magma, so to speak.
I like that. Dipped our toes into the magma.
There's so much more to explore.
Well, I'm excited to dive in deeper, but I think we need to let our listeners' brains cool down for a bit.
Sure.
We'll be back soon to explore some of the most fascinating and potentially groundbreaking applications of this incredible science.
That's good. So before the break, we were talking about how these volcanic minerals are like little time capsules from deep inside the Earth.
Yeah.
But their impact goes way beyond just telling us stories about the past.
Hmm. Okay. I'm intrigued you're saying these volcanic processes, the same ones that forge these incredible minerals,
Hmm.
could actually hold the key to some of our biggest challenges today.
Exactly. Take geothermal energy, for example.
Geothermal energy.
It's essentially harnessing the heat from within the Earth
Mm-hmm.
to generate clean electricity.
Okay.
And where does that heat come from? Well, a lot of it is thanks to those same fiery processes that create volcanoes.
So instead of fearing volcanoes, we could actually learn to work with their power. That's a pretty radical shift in perspective.
It is.
Yeah.
And it's not as futuristic as it sounds.
Yeah.
People have been using geothermal energy in basic forms for centuries. Think hot springs.
Oh, yeah.
For bathing and heating.
Right.
But now we're talking about scaling it up,
Right.
using it to power entire cities.
Wow. But how do we actually get that energy? I'm picturing us drilling straight into a volcano, which sounds a little terrifying, to be honest.
No, don't worry. It's not quite that dramatic.
Okay.
While tapping into magma directly is something that scientists are exploring,
Mm-hmm.
most geothermal plants work by accessing reservoirs of hot water and steam that are found underground.
So like giant underground hot tubs.
Kinda, yeah. You could think of it that way.
But how does that water get so hot in the first place?
That's where the volcanic connection comes in.
Okay.
Even in areas without active volcanoes, the Earth's crust can be incredibly hot, just a few miles down.
Oh, really?
And remember those tectonic plates we talked about earlier?
Yeah.
Well, their movement
Okay.
creates these cracks and fissures, allowing water to seep down and get heated up by the Earth's internal furnace.
Ah, okay. So it's like nature's own boiler system.
Exactly.
But how do we actually tap into those hot water reservoirs to actually generate power?
Well, sometimes the heated water rises back up naturally, creating geysers or hot springs.
Right.
But for geothermal power plants,
Yeah.
we drill wells to access these reservoirs deep underground.
Hmm.
Then the hot water or steam is piped up to the surface
Right.
to drive turbines, which in turn generate electricity.
So it's a clean, renewable source of energy powered by the Earth itself. That's amazing.
It really is.
But is there enough of this geothermal energy to go around?
That's the big question. Geothermal resources aren't evenly distributed across the planet.
Places like Iceland with lots of volcanic activity,
Right.
they're geothermal hotspots.
Makes sense.
But even in areas without those obvious signs of volcanic activity, there's still potential.
Okay, so what about those places that aren't sitting on a volcano? Are they just out of luck when it comes to geothermal energy?
Not necessarily. There's something called enhanced geothermal systems, or EGS for short,
EGS.
which aims to create artificial geothermal reservoirs,
Artificial.
even in areas where they don't naturally occur.
Hold on, you're saying we can create our own geothermal hotspots? How does that even work?
It involves drilling deep into hot, dry rock
Hmm.
and then fracturing it to create permeability.
Permeability.
Yeah, basically making it more porous.
Okay.
Then cold water is injected
Okay.
and heated by the surrounding rock,
Mm-hmm.
and then pumped back up as steam to generate electricity.
Wow. So we're essentially mimicking nature's process of creating those hot water reservoirs.
Hmm.
But in places where they don't exist naturally, that's pretty ingenious. It is. And it has the potential to significantly expand the availability of geothermal energy.
That's exciting.
It is. But like with any new technology,
Right.
there are challenges to overcome.
Such as, what are some of the hurdles we need to clear to make geothermal energy a more widespread reality?
Well, one challenge is cost. Building these geothermal plants, especially the ones using EGS technology,
Right.
requires a significant upfront investment.
Okay, so money's an issue. What else?
But there's also the issue of induced seismicity.
Induced seismicity, so basically earthquakes.
Yeah.
I can see how fracturing rock deep underground could be a recipe for disaster
Yeah.
if it's not done carefully.
Exactly. That's why research and development in this field is so crucial. We need to figure out how to harness this incredible energy source safely and responsibly, minimizing any potential negative impacts.
So geothermal energy seems like this incredible opportunity,
It is.
but it needs to be approached with caution. It's like we're learning to work with this powerful force of nature,
Yeah.
and respect is key.
I agree with that. But even beyond geothermal energy,
Okay.
there's so much more to explore when it comes to the potential of volcanic material.
I'm all ears. What else have these fiery furnaces cooked up for us?
Did you know that scientists are exploring the use of volcanic ash
Volcanic ash?
as a potential tool for carbon capture?
Volcanic ash to capture carbon. That sounds counterintuitive. given that volcanoes release carbon dioxide during eruptions.
It might seem paradoxical,
Yeah.
but volcanic ash is incredibly porous,
Mm.
meaning it has this huge surface area,
Okay.
and that makes it really good at absorbing things.
Like carbon dioxide.
Eventually, yeah.
So we could take this material that's often seen as a nuisance, a consequence of these destructive eruptions,
Right.
and turn it into a tool to fight climate change.
Exactly. It's about turning a potential problem into a solution.
Wow.
And this is just one example of the unexpected ways we can utilize these volcanic materials. There's so much more to discover.
It's amazing to think we've gone from using obsidian for tools way back in the Stone Age to now potentially using volcanic ash to combat climate change. It really is remarkable how intertwined these volcanic materials have been with human history and innovation.
It is. It really highlights the power and the versatility of these natural processes. And we've been talking about geothermal energy and carbon capture, but these potential applications of volcanic chemistry, they go even further.
Oh, okay. I'm ready for another aha moment. What else can we do with these fiery gifts from the Earth?
Well, scientists are exploring ways to use volcanic materials in a whole range of things, from construction to agriculture.
Really?
For example, volcanic rock can be used as a natural fertilizer,
Interesting.
releasing essential nutrients as it breaks down.
Mm-hmm.
And remember those unique crystal structures that we talked about earlier?
Yeah.
They're inspiring the development of new types of batteries
Wow.
and even water filtration systems.
That's incredible. It seems like this whole world of possibilities is opening up as we learn more about volcanic chemistry. I think what struck me most throughout this conversation is this shift in perspective. Instead of viewing volcanoes as purely destructive forces, we're starting to understand how we can work with their power, their raw energy, for good.
That is a key takeaway here, recognizing the interconnectedness of things. Volcanoes, for all their power and potential for destruction, they are also integral parts of the Earth's system.
Right.
They shape landscapes, create fertile soils, they even influence our climate.
It makes you realize that even in the face of these seemingly uncontrollable forces of nature, there's so much we can learn and apply to solve some of the challenges that we face. It's like nature's offering us these clues, these blueprints, if we're willing to pay attention.
And that's what makes science so fascinating. It's
Yeah.
about unraveling these mysteries, understanding how things work, and then using that knowledge to create a better future.
So for our listeners who are now itching to drop some volcanic knowledge at their next cocktail party, what's the key takeaway? What's the one thing they should remember from this deep dive?
I'd say remember this. Those fiery mountains that we call volcanoes, they're not just geological wonders, they're also incredible chemical factories. And by understanding the processes that happen within them, we can unlock a wealth of potential, from clean energy to sustainable materials and beyond.
It's like a reminder to never underestimate the power and ingenuity of nature. And maybe, just maybe, by learning from volcanoes, we can forge a more sustainable and innovative future for ourselves.
Absolutely.
Well, that's about all the time we have for today. Thanks for joining us on this deep dive into the fascinating world of volcanic chemistry.
It was a pleasure.
Until next time, keep exploring and keep that curiosity burning bright.